Folks, because I desperately want to make sure you have plenty of time to study for your test, and I don't want you to have homework over the Christmas week break, I'm going to go straight to the tone. We're going to finish this lesson on Monday. The homework from Monday, though, is to try that page 243 and come here with questions to ask. Also have questions from section 5.2 SALT's homework. Don't just copy the answers that I gave you. You ready? The last topic. Julia, we've tried to divide compounds into types, thank you. Acids and bases, salts, and the last one is organic compounds. Turns out all compounds can be classified as either organic or inorganic, non-organic. Now, a lot of these rules were set up before we understood lots about chemistry, so you're going to hear me use phrases like usually or in general or mostly, because much like everything, Allison, there's always an exception to everything that I've been showing you. But in general, organic compounds contain, what's capital C? Carbon. We are carbon-based life forms. We are human organisms. We are organic. And usually contain, what's H? Hydrogen. Is it okay if I use the chemical symbol abbreviations instead of writing out the words? They're abbreviations. I tend to abbreviate. While inorganic compounds don't contain carbon. However, like I just finished saying, Julia, there are exceptions. Can you all, if anybody has their pink periodic table, you probably might want your pink periodic table out. Taylor, you got it? Flip it over on the back. There are some polyatomic ions that start with a C for carbon. Okay? The carbonates. Those are not organic, even though they have a carbon. They're bonded to that oxygen molecule, the CO3 and the CO2 carbon dioxide, and don't freak out about those. So, some exceptions. Carbon monoxide, CO. Carbon dioxide, CO2. CO3 2 negative, which is carbonate. And then there's something that we'll talk about. They're called carbides. These contain carbon, but they're not organic. Inorganic. However, over half of all known compounds are organic. What do they contain? Carbon. Carbon bonds with many things. On the periodic table, carbon is one of the few elements that does not have an ion charge. Dylan, did you notice that? It's blank. Carbon and silicon, as it turns out, don't have an ion charge in the top right corner. Because it turns out it almost never forms. It can. We can force it to. As I've said, there's always exceptions. But the vast majority of the time, if you see something with carbon, it's covalent. It can be part of a polyatomic ion. And remember, those ones are covalent. They bond ionically with other compounds, but Jaden, those polyatomic ions form with covalent bonds. Carbon has how many electrons in its valence shell? Count. Rylan, you can count from the left. 4. And so, you know what that means? It's exactly half full. which is too many carbons to easily lose or easily gain. So it tends to share. Covalent. How many electrons does it need to have a full valence shell? So it tends to have 4 bonds. Well, no, I lied. It can form 2 or 3 bonds to one other atom. These are called double or triple bonds. They're very strong. Most explosives, for example, have carbon in double and triple bonds, and when you break them, energy. Okay? It will usually bond with atoms close to it on the periodic table. What's close to carbon? Well, O2. Although it can bond with a single O as well. Nitrogen, sulfur, phosphorus. All of the halogens, what family number are the halogens? Okay, I'm just going to put number 17, family number 17. And what's very special about carbon, Jasmine, very useful about carbon, is it can also bond with itself to form long chains. We call them polymers, many. Oils and plastics or complex ring. All plastics contain carbon. In fact, vast majority, if it's not metal, if it's something synthetic like this, well, wood is carbon as well. Hey, carbon is really good at forming stuff. We use it all over the place. No other element can form as many stable compounds as carbon. It's like the uber pop. You know what? It's like the Kevin Bacon, except everybody's done a movie with Kevin Bacon. Carbon. It's like been in everything. It forms. Hey, I think I've told you. If you add up the number of things that carbon can form, it adds all of the other elements in the universe combined. Oh, so it's not a coincidence that we are carbon-based life forms. The odds say we would be, because most compounds are carbon-based. When we look for alien life in outer space, Julia, we are looking for carbon-based life forms, not because we're not creative and can't imagine life that doesn't have carbon-based, but because the odds are it will be, because most compounds are carbon-based. Representing organic compounds. What makes it organic has a carbon and usually a hydrogen. How can we represent them? 4 ways. First way we've already seen. Let's do it this way. Molecular formula. Shortest molecular formula. Simple, but it doesn't show what it looks like, and it turns out a lot of carbon compounds, the reason they behave the way they are is what they look like on a molecular level. That determines what else they can bond with. As an example, CH4. By the way, what would we call CH4? Technically, but you know what? Turns out we're going to give this one a special name because it has important properties. You've all run into it, usually unpleasantly so. No. Well. It's what makes people smell after they've eaten dinner and been a little uncareful. You've all run into it. You've all run into them. Okay? Methane. That's the smell that you go, ooh, yeah. Another way that we can show you, another way that we can write it is with a structural diagram. Sort of like a Lewis diagram, but even lazier because we don't bother showing everything. This shows how some parts of the atoms are joined, but the problem is we're drawing it on a flat piece of paper, and Tyra, most of these are 3D atoms, so it's very tough to show. Here's an example. There's CH4, there's methane, structural diagram. Now, you ready? These are covalent bonds. How many electrons does each one of those count for? 2. So each hydrogen has its 2 electrons. It's happy. And carbon has its total of 8. Except that's not really what it looks like. That makes you think that methane is flat. There's another kind called, very creatively, ball and stick, because they're made up of little balls and little sticks. These are great in that they show the 3D. They suck in that I can't draw them to save my life. If those of you that are artistic might like these, you may have already noticed, am not anything remotely close to being even partly artistic. Turns out methane really looks like that. It's kind of got a pyramid bottom with 3 hydrogens and 1 hydrogen sticking out on the top. It's a tetrahedron for those of you who are mathematically inclined. Looks like that, where the sticks represent the covalent bonds. And the last one, we're going to pause here. We have what are called space-filling diagrams. These are probably the most accurate in that they show sort of the electron density. I've told you, electrons are not little dots. They're kind of clouds. And so we represent the atom as kind of a cloud of electrons, and we kind of show you how it's all put together. Have a seat, Taylor. Oh, Cameron, we miss you, sick boy.